Good evening, students. So now we are going to discuss about dielectric strength. What are dielectrics? We already have studied that dielectrics are insulators. Okay, so the electric field is no longer affecting these materials. Okay, now students, there is a further case or there can be a condition when there will be a breakdown of dielectrics. Means the dielectric will lose their insulator property, and that electric field which can break their insulator property is known as its dielectric strength. So suppose we are having a dielectric material, what we will wish to have a material with least dielectric strength or to have a material with more dielectric strength. So our answer is very clear. We want a material with having greatest dielectric strength so that it can exist in a condition like that. Means a maximum electric field is even not affecting it. So we want to increase the threshold value on which the dielectric material will lose its insulator property. And why this happens? Means why in the maximum electric field the dielectric will lose its property. So the answer is very clear. Okay, we already know any matter is made up of, means there is a atom. Okay, inside the atom there is a nucleus. Okay, and inside the nucleus there are positively charged particles known as protons and negatively charged particle known as electrons. Now students, these electrons are bonded to the nucleus. Okay, these electrons are not free to come out. Okay, means these are bonded with the nucleus, so we require an energy. Okay, an electric field that can take out this electron. Okay, that free electron, the electron will be free for the conduction. So dielectric materials are basically insulators. So they require a very large amount of potential or very large amount of electric field for one electron to go out from the nucleus. So the maximum field strength after applying which the dielectric field will lose its dielectric property is known as dielectric strength. Okay, so what in the bookish language we have written the maximum electric field that can exist in a dielectric without causing the breakdown. This condition, when one electron will be come out, that condition is known as breakdown condition. Okay, so this is the maximum electric field which can be tackled by that particular material. Okay, so there is one column in which I have written dielectric constant, and it's a dielectric strength. Okay, what should be the unit of dielectric strength? Already I have told you electric field, and what is the formula for electric field? E is equal to minus dV upon dr. So dV is volt and dr meter. So volt per meter, but here the conventional unit which we have used is kilovolt per millimeter. Okay, so this you have to remember. This is dielectric constant K. This I will tell you. Okay, unit is volt per meter. Already I have explained. Now, students, the dielectric strength for vacuum is infinity. Okay, so suppose in a capacitor, inside a capacitor, the dielectric material is vacuum. What is the meaning of vacuum? That nothing is present. So the dielectric strength is infinity. Infinity electric field is required to get the breakdown of this vacuum. Okay. Now suppose we have air. So air can be, there are conditions that air can be ionized and that air will start the conduction. So that value is 0.8. Water, we cannot define it. For paper, it's 14 kilovolt per millimeter. Now, what is the meaning of this dielectric constant K? This we have written. So, the dielectric constant is totally different from dielectric strength. How this is different? So, K is equal to, if you remember, we already have done. K is actually that how much time the capacitance of a conductor will increase when we will introduce the dielectric slab in the capacitor. We have calculated the capacitance of a capacitor, okay, and that was given by C is equal to epsilon naught A upon D. Now students, suppose I have introduced a dielectric material inside the plate of capacitor, okay, between the plate of capacitor. When I will insert a dielectric slab inside the plate of the capacitor, I am just drawing it roughly. to understand it. Okay, we have a plate of capacitor. We have placed the dielectric material. So, suppose the dielectric constant of this material, which we have introduced inside the plate of capacitor, is K. So, the new capacitance of this capacitor will be K epsilon naught A upon D. Okay, so don't worry about this. We are going to do this derivation, okay, later on. So just understand the fact. Now, what will be the ratio? The ratio of C dash and C will be K when you will divide it. Okay, so C dash will be how much? Ck. So what we understood from this? That the new capacitance of the material when dielectric is introduced is K time the old capacitance. Okay, so dielectric constant is the number that tells us that how many times the capacitance of a material is increased when we will introduce it between the plate of capacitors. Okay, so in vacuum you will introduce, means vacuum is used as the dielectric material, that how many times the capacitance will increase? One time. Capacitance will increase one time because already vacuum is nothing is present. Okay, so if earlier the capacitance was epsilon naught A upon D and we have filled vacuum, means nothing we have filled, then the capacitance will increase by how many times? One time. Okay, so it will remain same. So the dielectric constant for vacuum is 1. For air, that is 1.0004. So it's little greater than that of vacuum. Okay. Sometime for calculation we consider both as equal one, but here we are distinguishing both the things. Now for water that is 81 and for paper that is 3.5. So please don't be confused with dielectric constant and dielectric strength. Dielectric strength is the electric field, the maximum electric field on which the dielectric material will not lose its dielectric property. Okay, and after this, means after 0.8, suppose I am increasing the electric field more than 0.8 for air, then chances are that the ionization will occur for such kind of material. Okay, for air there will be ionization and the dielectric will lose its property. Okay, so this I hope you understood. And capacitance, that how many times the capacitance of a material will increase, that is known as the dielectric constant. Okay, so these two are the things which I have distinguished. I hope you understood this topic. Thank you. God bless you.